The world has always chased speed, but there are moments when speed stops being just a number and becomes a symbol of human ambition. The SCMaglev is one of those moments. It is not simply a train moving faster than anything before it, it is the result of decades of patience, precision, and belief that the limits of ground transportation could be rewritten. When this train glides forward, it carries with it the story of how engineering, physics, and national vision can merge into a single, breathtaking achievement. The idea behind the SCMaglev was born from a simple yet radical question: what if a train never touched the tracks at all? Traditional rail systems, even high-speed ones, are limited by friction between wheels and rails. As speed increases, vibration, noise, and mechanical stress also increase, creating natural barriers that engineers struggle to overcome. The solution proposed by Japanese scientists was magnetic levitation, a concept that allows a train to float above the guideway using powerful superconducting magnets. By eliminating physical contact, friction is almost entirely removed, unlocking speeds that conventional trains can never reach. Development of this technology was led by Central Japan Railway Company, an organization known for operating the iconic Shinkansen. Research began many decades ago, long before the world was ready to imagine trains traveling faster than most aircraft during takeoff. Early experiments were modest and filled with challenges. Superconducting magnets required extremely low temperatures, stability was difficult to maintain, and energy consumption raised serious questions. Yet year after year, test after test, the technology matured. The SCMaglev operates on a principle called electrodynamic suspension. Once the train reaches a certain speed, magnetic forces lift it several centimeters above the guideway. Guidance and propulsion are also handled magnetically, with linear motors pulling the train forward. The result is a smooth, almost surreal motion. Passengers do not feel the familiar vibration of steel wheels. Instead, there is a sensation closer to flight, but without turbulence. Acceleration is powerful yet controlled, and the silence inside the cabin contrasts sharply with the extraordinary speed outside. During testing on the Yamanashi Maglev test line in Japan, the SCMaglev achieved a recorded speed of 603 km per hour, setting a world record for rail vehicles. This was not a brief or unstable burst of speed, but a controlled run that demonstrated the system's reliability. Engineers proved that the train could safely accelerate, cruise, and decelerate at speeds that once belonged only to experimental aircraft. For many observers, this moment marked a turning point in transportation history. What makes the SCMaglev especially fascinating is that its purpose is not just to break records. The true goal is to transform everyday travel. The planned Chuo Shinkansen line will connect major cities in a fraction of the time currently required. Journeys that once took hours could be reduced to minutes. Business travelers, commuters, and tourists alike stand to benefit from a system that redefines distance. Entire regions could become economically closer, reshaping how people live, work, and interact. Safety has always been a central focus of the SCMaglev project. High speeds naturally raise concerns, but the technology is designed with multiple layers of protection. Because the train is guided by magnetic forces, derailment risks are dramatically reduced. Earthquake detection systems are integrated directly into the infrastructure, allowing the train to stop almost instantly if seismic activity is detected. Extensive testing has simulated extreme conditions, ensuring that the system can respond reliably to emergencies. Energy efficiency is another crucial aspect. While the SCMaglev requires significant power to operate its magnets, the absence of rolling friction and the efficiency of linear motors help balance energy consumption, especially at cruising speeds. Engineers continue to refine the system to reduce environmental impact, incorporating regenerative braking and advanced power management. Compared to air travel over similar distances, the SCMaglev has the potential to offer a cleaner alternative with lower overall emissions. Inside the train, design meets comfort. The cabin layout emphasizes space, stability, and quietness. Large windows offer views of the landscape rushing by at unimaginable speed, yet the experience remains calm and composed. Pressure control systems ensure that passengers are not discomforted when entering tunnels at high velocity. Every detail reflects a philosophy that speed should never come at the expense of human comfort. The SCMaglev also represents a cultural statement. In Japan, railways are more than infrastructure, they are a point of national pride. The discipline, punctuality, and safety of Japanese trains are admired worldwide. The SCMaglev continues this tradition, pushing it into the future. It signals a commitment to long-term innovation, even when development takes decades and requires enormous investment. Globally, the SCMaglev has sparked both admiration and debate. Some countries view it as the ultimate solution for high-speed ground transport, while others question the cost and complexity of building entirely new guideway. Yet even critics acknowledge the technological brilliance behind the system. It stands as proof that with enough determination, humanity can overcome physical limitations that once seemed absolute. Looking ahead, the implications of the SCMaglev extend far beyond a single route or country. The knowledge gained from its development influences other magnetic levitation projects and inspires new approaches to transportation. Concepts such as ultra-fast intercity networks and even vacuum-based systems draw lessons from the successes and challenges of the SCMaglev. It is a foundation upon which future ideas are built. At its core, the SCMaglev is a story of persistence. It took generations of engineers, scientists, and planners to bring it from theory to reality. Many who began the work never lived to see the record-breaking runs, yet their contributions remain embedded in every magnet, every control system, and every meter of guideway. This continuity of vision is rare in a world that often demands quick results. When the SCMaglev finally enters full commercial service, it will not just carry passengers from one city to another. It will carry the weight of history and the promise of what is possible when imagination meets discipline. Standing on the platform as the train arrives, silent and poised, one realizes that this is not merely the fastest train in the world. It is a glimpse into the future of movement itself, where distance shrinks, time bends, and the boundaries of human achievement are pushed ever further forward.